We are doing what's called slope intercept form. And I don't know why I started on this slide. We don't need it quite yet. So I'll be erasing this mostly. So when we did graphing last chapter, we made a table of values. In the case of a line, and actually in the case for the rest of the year, is that we're going to learn some tricks to make the graphing easier. So if it's a line, now I know it's a line, I know it's linear, if I have a power on x that's a 1, okay? And the power on y is also a 1. Now mostly it's x that matters, usually y doesn't ever have a power on it. It's usually x that has something on it. So if I just have an x and nothing else, now I can have a number in front of it or something like that, but if the power, the exponent, that would be this thing right here. If it's a 1, okay, or it's not written, then it is a 1, so that means I have a line. So these are all lines. So if you graph it and you do not get a line, guess what is wrong for the whole chapter? It's not a line, it's wrong. It should be a straight line. Alright, so what is this slope-intercept form? Yesterday, or actually Friday, what we did is we did slope. And we said slope is rise over run, which we said is change in y over change in x. And we actually used this symbol, we used an m to represent that. M equals change in y over change in x. And usually when you see m, that is what we're talking about. We are talking about slope. My button keeps disappearing, so that's making this really hard to do. Alright, so I need to erase. And my thing's disappeared. I don't know why it's disappearing. Oh, my computer's having a hard time. Okay, there we go. Maybe it's just having a hard time to receive. Alright, so I'm going to erase all that just because, so that I can see. So I guess I have to stand up. Alright, here is our slope-intercept form. Y equals mx plus b. Now these are going to represent something. Y is my dependent variable. Y is usually my dependent variable. That means it depends upon the value of x. So we have to calculate it. Okay, m is our slope. And x is our independent variable. We do not calculate that. And b, that's going to be our y-intercept. Well, what is an intercept? It's where we cross the y-axis. So I'm going to give you an example of this. Let's say that I want to graph the equation y equals 2x minus 4. Alright, well let's identify stuff. M, which is our slope, is what? 2 over 1. Okay, so this is my example. Y equals 2x minus 4. So my slope, notice I didn't say x on this. X is not part of the slope. My slope is 2 over 1. My y-intercept is not 4, it's negative 4. So here's what I do. I start at the point, I start at this point. Y equals negative 4. Do you see that that's right here? Negative 4. And from there, I'm going to use my slope. My slope says go up 2 and write 1. Up 2 and write 1. Up 2 and write 1. And boom, without a table of values, I've graphed my line. Make sure I put an arrow on it. And notice I have all the parts. See, here's my y-intercept. And see, I used my slope. Up 2, write 1. Up 2, write 1. Do you see how I got that? All right, let's say I wanted to graph this one. Y equals negative 4/3 x plus 2. What's my slope? What's m?
Negative 4.
Negative 4/3, yes. And what's my y-intercept?
2.
It's 2. Okay, so I'm going to plot 2. Well, what do I mean 2? I mean the point 0, 2, right? Because x is 0. So there's my point, 0, 2. Notice it's a y-intercept, so which axis is it on? Y. So many of you, I'm telling you, are going to go on the x-axis. I don't know why you do that. It's a y-intercept, so it's on the y-axis. From here, I count what?
Down.
Down 4,
Right.
3. And then down 4, right 3. And I do that until I go clear across, and then I might reverse it if I have to. I connect my points, and there's my line. Does that make sense what I just did there? Now later, as in next chapter, we'll actually be calculating what this point is where these two meet. But for now, we don't need to do that. But just note, those two intersected somewhere. Okay? Alright, I'm going to erase all that. Well, get a nice clean slate here.
Are we supposed to write that right there on that graph?
You could. Sometimes I've given it like this. 2y minus 5x equals 8. Is this in slope-intercept form?
No.
No. So I need to get it to slope-intercept form. Well, when I need to get it to slope-intercept form, I need to solve for y. Often we just solve for y. We're going to solve for y, get y alone. So this is like a literal equation from like earlier in the year. Someone died, I guess. All right, we'll add. It's always bad news when I get a phone call during school. It's always bad. All right, so we'll add these. I'm gonna feel really bad if that was true. All right, so I'm solving for y. So I add 5x, so I get 5x. Now what do I do with this 8? It's just plus 8. And now what do I do?
Now you divide by 2.
I divide by 2. So I get. Now that's going to be everything divided by 2. I'm not going to change this to a fraction, to a decimal. I want to leave it as a fraction, so I have 5/2 x. And what's 8 divided by 2?
4.
4. Alright, so I'm going to write my answer over here as y equals 5/2 x plus 4. I'm going to erase all this so the work's out of the way, but we solve for y. So now I'm going to graph that. Now what's my slope?
5/2.
Yeah, 5/2, and what's my y-intercept? 4. Now I need to remember that's the point 0, 4. So at the point 0, 4, what do I need to do?
Go up 5.
I go up 5. Now notice that goes off my graph. That's okay, I'll just put a little dot up here. I'm not actually going to connect it, but I need to remember it's going up, right? I always go left to right first. Now, since it went off my graph, I'll reverse it. So instead of going up 5, right 2, I'll go down 5, left 2. I just put a negative in front of both of them. And then I can connect that. But I won't connect that last point because it's not where it should be. And that's my line. And anything with a positive slope, as I read left to right, should be going up. And anything with a negative slope should be going down. Any questions on this so far? All right, let's say I have negative 3y. Let's do minus 2x equals, let's say 3x minus 6. So in order to graph this, what do I need to do first?
So for y.
Solve for y. So yeah, we'll add 2x. So I'll get negative 3y equals 5x minus 6. And now what?
Divide negative 3.
And that's divide everything by negative 3. So I'm not going to change this 5/3 to a decimal. I'm going to move the negative up. Negative 5/3 x. And what's negative 6 divided negative 3?
2.
So plus 2. Do you see how I did that? I'll graph this one in blue. Where do I start?
2.
At y is 2. And then from there, I go down 5, 1, 2, 3, 4, 5, and right 2. I'll reverse it just to get that extra point. I want a minimum of 3 points. So for all of these, 3 points, minimum, 3. You can do more, but that's the minimum. I want your lines to extend across your graph. I don't want little stubs. I don't want something like this. No. I want to see it cross the y-axis and extend through. Okay, so no little stubby things. Any questions how I got any of this? Alright, that leaves us with one more thing to talk about from this section, and then we're going to practice. You guys good on slope-intercept form? You good? I hear one yes. How would I graph this? Y equals 4. Notice there is no x.
You just put the 4 on the y-axis.
Okay, I put the 4 on the y-axis. This is a horizontal line. So that's not enough. I need to draw. Y can be 4 at any of these spots. Do you see what I did?
Yes.
It's a horizontal line. What if I had x equals -3? There's no y or anything. That's a vertical line. We're going to want to memorize that. So I start at x equals -3, and that's a vertical line, so that's going straight up and down. You understand how I got that? So if I have x equals something, that's vertical. If I have y equals something, that's horizontal.